Okay, question 4 for HL, 7 for SL. So Professor we modeled the percentage of information retained by this function. So he reckons his students are they forget information after his lectures, and this is how he's modeling it. T is the number of days after the lecture. He found that one day after a lecture, students had forgotten 50% of the information retained. Find the value of P. Okay, so we have a situation like this. A, R of T is equal to 100 e to the minus P T. P is some constant. Now he's saying that students had forgotten 50% of the information retained. So that means when T is 1, when T equals 1, so that's after 1 day, R of T, which is the percentage of information retained, is 50% or half of this. So it's 50. So we can say 100 e to the minus P times 1, if you like, is equal to 50. Then I have e to the minus P equals a half, and then I can just solve this using a calculator. You can use numerical solve, or you can graph it. There's definitely only one solution here. Let's just graph it. I have e to the negative x. Got to use x, guys, because it's a graph. And then we draw another graph, which is a half, or 0.5, where they meet. So menu, analyze graph, intersection, lower bound, upper bound. They meet at 0.69315. 0.69315. Now you could, guys, if you're smart and you really want to give it an exact form, you can actually say, because if e to the minus P is equal to a half, then minus P, let me just do that over here, guys, hang on. If you want to do it this way, you can say minus P is equal to ln of a half, or P is equal to ln of 2, because a half is ln of 2 to the minus 1. And then you can make that minus ln of 2. That's how that works. So minus P equals minus ln of 2. P is equal to ln of 2. So there, yeah, that's the same thing. So, but that's perfectly fine. Part B, over here, use this model to find the percentage of information retained by his students 36 hours after his lecture. Okay, so I just need to find R of 36. R of 36 is 100 e to the power of negative P. Now P is now this 0.69315. 0.69315. T, which is 36. So let's do that on our calculator, guys. I am going to, let's just go back to here. I'll do 100 times e to the power of minus 0.69315 times 36. Just make sure you type it in all correctly. And I get 1.4. Have I done something wrong here, guys? This seems strange. Okay, I have done a mistake. I realize it now. And I think, guys, I'm going to leave that mistake in there, because sometimes those mistakes are nice to kind of... But you see, notice how when I saw the answer, I thought this must be something wrong here. So that's what I want you to do in an exam. You always check the answer and see, does that make sense? And it didn't make sense that they basically lost every single bit of information after 36 hours. What's my mistake? Well, it's the number, T is the number of days after the lecture. So we don't put in 36 hours, we put in the number of days. How many days is 36 hours? Well, it's 1.5. It's 24 is 1 day. 36 is 1.5, so I'm going to put in 1.5. Okay, let me do that again. Apologies. 100 times e to the power of negative 0.69315 times 1.5, 35.3552. 35.3552. He uses model to find the percentage of information retained. So this is the percentage of information retained. If you want to put it as 35.4%. So that's how much information they will have retained after 36 hours. So just be careful. It's not how much they've lost. The whole thing is retained. That's how much they've retained. This is how much they've retained. Be careful. If they did ask how much had they lost, then it would obviously be 100 minus this. Okay, part C. Based on his model, Professor Wee believes that his students will always retain some information from his lecture. State a mathematical reason why he might believe this. Okay, well, if we go to our graph, guys. Well, let me draw you the actual graph. Let's get rid of this. And let's get rid of this one. I'm going to actually draw here. I'm going to draw 100 times e to the power of negative 0.69315x. So this is the graph. This is the model. And as I move along, what's happening here? Well, as x gets bigger, there's an asymptote, and the asymptote is at y equals 0. But that asymptote means it never actually approaches it. So if I move along, it approaches it, but it never actually touches it. So if I move along here, as x gets bigger, this y value will never get to 0. Now on my calculator, it probably will get to 0 just because it'll round it. But, well, maybe it doesn't. Look, in theory, it'll never reach 0. It'll just get smaller and smaller and smaller. Right? Yeah. Here the calculator has decided to round it, but really it'll never reach 0 because it's an asymptote. So I'm actually going to write here asymptote at y equals 0. Therefore, percentage of information retained cannot reach 0. That's it. That's definitely enough for 1 mark. Okay, finally, part D. Write down one possible limitation of the model. Now, look, there's lots of limitations of the model, but they're very much specifically looking for a kind of mathematical limitation. So this is a limitation. I think let's stick with this. It can never reach 0, but imagine this model assumes t can go on forever and ever and ever. But what if the number of days is 1,000,000? Will the student even be alive at that point? So that's one clear reason that t, well, students, yeah, that's an easy one. Students can't live. Students can't live forever. That's one limitation. Second one might be that it also assumes that if t is 0, when t is 0, they've retained 100% of the information. So it assumes that as soon as the lecture is over, or 0 days after the lecture, so even for that entire day, they remember every single thing in the lecture, which I know as a teacher is definitely not possible. So that would be another obvious reason. Okay, that's that question done.